Right, so I'm going to do a wrap-up lecture on the second week here, and we're really going to look at only look at two of the problems, and that's the distance between 2 points and the roots of the quadratic equation. So we're going to start with the distance between 2 points. One of the problems that I have with Moodle is the easy ability to do a square root sign. Now, I think it can be done, but you have to use a special language called LaTeX, which I don't know how to do, and I haven't gone trying to figure it out. So I've just said, shown the formula here, and I've shown it to the power of a half. The power of a half is effectively a square root. So just to show you there, I'll just draw out what the formula should be. We have 2 points, so we'll show a point here and a point here, and we have a line drawn between them, from there to there. Now these points are given with a coordinate x1, y1, and x2, y2. Now, in fact, we can use Pythagoras here, so make this into a triangle with a right angle in it. Okay, and what we can do is we can quite easily find this distance here by saying x2, which is the distance across on the x-axis at this point here, and this is x1, the distance over here. So the distance between those 2 points is going to be x2 minus x1. And the other distance here, this distance here, is given by y2, sorry, I should say y2 minus y1. And if you know your Pythagoras theorem, you know that it's this side squared plus this side squared equals that side squared. So what we can do is we can square this and square this, add the two together, and then get the square root of that in order to find this one here, which we'll just call the distance. Excuse me. No, so that's the distance there. So that's the way it should have been written in here, but unfortunately I had to write it to the power of a half. Now, one of the things that we're going to find here is that to square something in C, we have to do something like this. We'll call this x2 minus x1, and we just basically multiply it by itself. There are other ways of doing it, but this is probably the simplest for just a squaring. x1. Okay, so that's squared, and then we'll add the other one to it. y2 minus y1 by, remember that's an asterisk there, y2 minus y1, and we'll put the whole lot of that in brackets then, and we get the sq or t, the square root of that, and we can then assign that to something, so we can put distance over here, dist. Okay, so that's how we're going to do the formulas. Now, looking at the program then, or the exercises you were asked to do, write a program to find the distance between 2 points. The user should be asked to input the x and y coordinates for the 2 points, and the distance between the 2 points is given by the formula. This should be calculated by a function, so we're going to have to write a function to do it separately. The square root of a number called num1 can be found by using the square root num1 function. So the square root function, we give it the number, which requires us to include the math.h at the top. An important thing, if you were given this as an assessment, make sure you at least do the parts that you're able to do. Even if you can't do the whole lot, you should certainly be able to ask the user for the different coordinates and so on. And you should probably be able to make the guts of a function in order to do it as well. So make sure you do the parts that you can do, even if you can't do it all. So we'll start writing this function here, and I'm going to just pause there while I write the basic body of it. Okay, so there we have the basic function of the program written, and clearly what we're going to have to do is we're going to have to make a number of variables in order to deal with this. Looking back at the information that we have here, we're clearly going to have a distance variable. We're going to have a variable called x1, we're going to have a variable called y1, a variable called x2, and a variable called y2. So you're going to have to ask for those 4 variables and then calculate the distance variable. So we'll write those 5 variables in there. Should they be floating point or integers? Well, really and truly, they should be floating point because of the fact that coordinates could easily be 4.5 but on the x and 3.2 on the y. There's no reason why it wouldn't be that way. And particularly when we start squaring and then getting the square root of numbers, we could easily end up with a result that's a floating point number. So certainly distance, but I would say also the other four variables should be. So write float x1 x2. Doesn't really matter the order we put these in here. Obviously the order we take them in will matter. y1 so that's the distance. Now obviously we have to ask the user for the two sets of coordinates. So I'm going to ask these as separate ones. So I'm going to say printf first set of inlets. Put that there. I should probably really say separated by a space. I won't just for ease of fitness on the screen here, because you may notice that I've the text size slightly bigger here so that it's easier to see on the video. But you could probably put in, separated by a space, given that you're going to be putting in the two numbers in each case. So scanf, and these are floating point numbers, so we're using %f. Going to put a space in between them and another one there. Be wary there. I've seen a few people put an extra space here. You shouldn't do that because it actually causes quite a lot of problems. The scanf function tends to be a little bit problematic from that point of view, so do be wary of it. It can give you a little bit of trouble some of the time. So just try and use it carefully. So I'm going to put it into x1, and obviously the next one then is y1, because that's the first coordinate will have to be made up of an x and a y. Please enter the second. Okay, so that's our numbers taken in there. What we should now do is say distance is assigned distance calc. So this is going to be a function. I haven't written the function yet, but this is what I plan to put into it. So I want to send it the four coordinates, or the four numbers of the two coordinates, and I want it to return to me the distance. So I'll say x1, y1, x2, y2. That. And lastly then I'll print it out. Print out the results. Is %f. And I'm going to put a slash in at the beginning of this sentence. I'm going to do the same up here actually, because I have a feeling it won't go into a new line otherwise. It may do, but just to be on the safe side, we'll put it in there. And we'll put a slash in here as well. Now, and I'm going to put in distance for that. So that's it for the main function. Remember, we have to write a function, this function here, to actually do the calculation for us. So I'm going to write that up here. I could just write the name of it up here and do the body down below. I'm going to write the whole lot up here, but one way or the other it'll work. So you can clearly see down here that this is going to have to return a floating point number to me. So I'm going to write float here as the return type. I'm going to write the name as being distance calc. I'm going to ask it to give me four floating point numbers: float x1, y1, might be wondering, does the order matter here? It very much does matter in this case, because you expect to put the coordinates in the correct order, or otherwise we'll get the complete wrong answer. So it does matter in this case, unlike where we were declaring them earlier, where it didn't really matter. And clearly what we're going to return from this is the distance. So I'm going to put that. I'm actually just going to call it NCE, just to show you that it's that it can be a different variable from the one down below. But in actual fact, we'd get away with just calling it DIST. It wouldn't be confused with this dist down here. There wouldn't be a problem. Same as this x1 down here is not the exact same as that one there, but they'll end up with the same numbers in them because we pass it that way. Right, so now we do the actual calculation. So we'll have to make a variable called distance, and we'll say distance is assigned the square root SQ over T of the numbers here. So the whole lot in here, we say x2 minus x1. Do that twice as I showed you earlier. x2 minus x1, because that's going to square it. Then we're going to add to that y2 minus y1, y2 minus y1. Okay, and so that's the full formula there. That's the squaring of the first of the first one. That's the squaring of the second one. Add the two together, and then the whole lot of that number is inside the square root function, so it's going to get the square root of it. Put that into distance. Distance is going to get returned as a floating point number, and that ends up in dist back here when this function is called, and then that's printed out there. Okay, so remember how this thing all works. The main functions, we start at the beginning of the main function, we declare these 5 variables here. We ask for the first pointer, the first set of coordinates. We ask for the second pointer, the second set of coordinates. We pass those 4 numbers to the distance calculation function, which up here we can see is expecting those 4 numbers in that order, and we then make another floating point number called distance, and we set distance equal to the square root of these ones squared plus these ones squared. That'll give us the calculation for the distance. It'll return the distance to us, and it'll put that in dist, and then we'll print out dist by saying the distance is %f. Now, hopefully I haven't made any mistakes, but we'll find out now when I press the thing. So we have made mistakes. It says y2 is the first time it's been declared. So what have I written here? Well, if you see there, it's written as a capital letter Y2 here, so I've obviously put a capital letter somewhere along this line, and I see it now. So that should be a small y, so a minor mistake, but important nonetheless. So the first set of coordinates. Now, what I should always do here is actually do come up with some numbers here for these values, because otherwise we won't really know if we've achieved the correct answer. So I'm going to start with x1 y1 of 1 1. Okay, so this is going to be 1 1 there. Okay, now I'm purposely going to add 4 to this to make that a 5 here. So at this point down here would be 5 5 1, and I'm going to add 3 up the way here, so that then becomes up here at this point becomes 5 4. Okay, so I'm going to put those numbers in. The reason I'm doing that is that it's a Pythagorean triple. What will happen is we go 4 squared plus 3 squared, which is 16, plus 9, which is the square root of 25, so the answer should be 5. So when I do something like that, it means then that I know that my distance should come out as the value of 5. So if it doesn't, so never test these programs without knowing exactly what the result should be, or otherwise you have no idea whether it's working correctly. So let's give it a go. 1 space 1, that's the first set of coordinates, and the second set of coordinates is 5 space 4, and we can see that the distance is 5 exactly. Okay, so that's how that program is done. Now, the next program that we want to look at is the we'll just have a look at it here. It's the roots of the quadratic equation. Now, we can see here these ones, ax squared plus bx plus c, and I've given an example there of 2x squared plus 5x plus 2 as being an example of that. In this case then, a here is a value of 2, b here is a value of 5, and c is a value of 2. Okay. Now, these are called quadratic equations. It's often advantageous to know where the quadratic curve crosses the zero line. These zero crossing points are known as the roots of the equation. To find the roots of the quadratic equation, you can use the following formula. Now, some of you will be able to do find the roots of this particular one, for example, in your head if you went at it, but we can use this formula in order to figure it out as well. So we'll write a program to take in a, b, and c values for the quadratic equation. You'll need to pass these to two functions to calculate the minus b plus and the one to calculate the minus b minus. So you can see there's a plus or minus here because each function can only return one answer. Then print out the two answers on the screen. Test the program for several quadratic equations. Some won't work and may cause crashes, and I'll explain that in a moment. So just to explain to you what a quadratic equation looks like. Well, it's showing you there what it looks like, but here's what how it appears on a graph. It looks like this. Okay, and the roots of any one of these are the places where it crosses the x-axis. Okay, so when you get a value, you might get a value of something like minus 3 here and plus 1 here, and they would be known as the roots of the equation. We can calculate that straight from the formula that we're given there. So I think the example, just to look at it again, is 2x squared plus 5x plus 2. Okay, and we said that that's equivalent to ax squared plus bx plus c. So the formula are as follows, and there's two different versions of it. One is minus b, and we said it's plus or minus, so we'll do the plus one first, plus b squared minus 4ac, so the square root of b squared minus 4ac, and all of that is over 2a. Okay, so we'll calculate this one out first. So minus b in this case is 5, so that's minus 5 plus the square root of 5 squared minus 4 times a, so that's 4 by 2 by c, which is also a 2, and 2 by 2 is 4, by 4 is 16. That's all over, by the way, 2 by a, which is 2 by 2. So altogether this comes out as minus 5 plus the square root of 25 minus 16, all over 4. 25 minus 16 will give me 9, so I have minus 5 plus the square root of 9, all divided by 4, so that's minus 5 plus 3 over 4, which is going to be minus 2 over 4, which is minus 0.5. Okay, now that's the first one, that's the first root. The next root is given as minus b minus the square root of b squared minus 4ac over 2a. And so remember, you're going to have to do a separate function for this one and a function for this one here. So that'll be minus 5 minus square root of 5 squared minus 4 by 2 by 2, all over 2 by 2. So that's minus 5 minus the square root of 9 all over 4. So that's going to be minus 5 minus 3 divided by 4, which is minus 8 divided by 4, which is minus 2. And so what that tells us, they're the two roots, minus 0.5 and minus 2, and that tells us, going back to this, that if we just grab this here and delete it, and we can delete these as well. What that tells us, just our answers again, are minus 2 and minus 0.5, so that means that the thing is going to look something like this, and these are going to be our 2 points, minus 0.5 and minus 2. Okay, there are the roots of our equation. So we're going to have to be able to put this stuff into C program. So once again, I'm going to just open a new file here. I'm going to pause for a moment while I write the basic body of the program. So there's the basic body of the program written. I'm just going to save that as a name. So file. Remember, when you're saving, make sure you save it as .c. So this is I'm going to call this quad.c. And go back to the question that you're asked here. Remember that this is this power of a half here means the square root of this section here. So what we have to do is we have to write a program to take in a, b and c values for the quadratic equation. So you don't actually have to write out the quadratic equation, you just have to take in a, b and c, so a 2, a 5 and a 2 in this case. And you will also need to pass those to two functions, two separate functions, one that's going to calculate the plus version and one that's going to calculate the minus. So you're clearly going to have to write a main function and two separate functions, one for the minus, one for the plus. They're going to have to return the numbers, and then you're going to print them out using the main function. So remember, if you were given this as an assessment, if you can't do it all, make sure you're able to do that you attempt the things that you can do, such as being able to take in the three numbers, asking for three numbers and taking them in with a scanf, writing the functions and what you're going to put in there, writing the correct variables and how you're going to do that and all that sort of thing. Only leave out maybe the small parts that you may not know, and you will still gain quite a few marks. So let's look at the variables that we're going to take in. I'm going to take in the a, b and c as integers. They possibly can be taken as floats in quadratic equations, although I haven't really seen that. So I'm just going to take them in as ints and int c. Now I'm going to have the two roots as well, root 1, and I'm going to say that's a float because we could easily end up, as we've seen in the previous example, with a floating point answer. So root 1 and float root 2. We're going to do a printf. Now coefficients is just the word that's used for a, b and c, the number that comes before the x squared, the x and then the unit. So please enter the coefficients a, b and c separated by spaces. Three integers here. Now we're then going to send them to two functions. I haven't written the functions yet, but that's fine. We'll write them in a moment. So root 1 is going to be assigned the value that's returned from the first function, and we'll call it quad minus. So it's going to do the minus b minus the square root of b squared. So we'll call that quad minus, and we'll send it a, b, and c. And we'll do root 2, and that's going to be quad plus. Can't use the plus sign or the minus sign. You actually have to use words in this case, because they're not appropriate in names of functions to use arithmetic operators. So that's the two of them, and then we print out the roots. Now, of course, we haven't actually written the functions yet to calculate these, but that's effectively how this is going to work. So we're going to have to write this function here and the other function there. So we'll write those up here. So quad minus, first of all. We're sending it a, b, and c, which are three integers. So we say int a, int b, int c. And it's going to return a floating point number, because that's what's going to end. We can see it's been assigned to root 1, so it's going to return a floating point number. So we'll write float in front of it. Now, and what are we going to return from this? We're going to return a root. Okay. Now I'll just call that we can use the same variable name in both of them, because they'll be kept separate by the fact that they're in different functions. So float root. And we say root is equal to minus b, and remember this is the minus one, so minus the square root of b squared, so that's b by b, minus 4 by a by c, and so that's what we get the square root of all of that. And then we put the whole lot of this, and we divide it by 2 multiplied by a. And I'm going to put that in brackets as well. I don't. The reason I put this in brackets is that didn't actually go in brackets for me there, and I hit the wrong button. The reason I do that is that what could happen is that the divide would actually be taking precedence over the multiply, because it happens first. So I might divide by 2 first of all, and then multiply the whole lot by a, which is not what I want. So I want to keep them separate there effectively. So that should return that root, and that root will return by this method into root 1. So what I'm going to do is I'm going to copy that function there. Which again, this one is I'm going to change this to plus. And that means I'm going to change this to a plus. And other than that, nothing else has to change. Now, pretty much ready to go there. I'll be very lucky if I've got away without making any mistakes, as you can say I am. So, syntax error before return, and there is indeed. In both cases I forgot to put in a semicolon, so do that there. Now, a, b, and c. So the example that we had earlier was 2, 5, and 2. And we can see that the roots are minus 2.0 and minus 0.5, which is exactly what we calculated. So we know that the thing should be working correctly. Now, I'm going to give you an example here where we come up with a number here that isn't going to work. Now, basically, we run into a bit of a problem if, in the equation here, if b squared is smaller than minus 4 times ac. So let's take a being a value of 4. So let's say it was 4x squared plus 5x plus 2. In that case, actually what I'll do is I'll just move on to another one here. So 4x squared plus 5x plus 2. That would be minus 5 plus or minus b squared, which is going to be 4 squared, minus 4 times a, which is 4. Sorry, this should be 5 squared, my apologies. 5 squared minus 4 times 4 by 2. That's all over 2 times 4, or 2 times a. Now the problem here is that when we calculate this out, we go minus 5 plus the square root of 25 minus, now 4 by 4 is 16 and 2 16s is 32, so there's going to be minus 32, which is minus 5 plus the square root of there's 7, so that's minus 7 over 2a. Now the trouble is that if we get the square root of a minus number, that's not actually possible to do. So even if that's, let's say that was minus 9, for example, square root of minus 9, you might think that the answer to that is minus 3, but minus 3 squared is minus 3 by minus 3, which is plus 9, which obviously is not the same thing. So you can't get the square root of a minus number, or you can, but it comes out as a complex number and you have to use the iota or I. So the problem is that if you do that in a computer program here, it won't be able to do that, and therefore it will cause trouble for you. So let's just run that and just show you that happening. So we'll put in them 4, 5, 2, and we can see we've got some very, very unusual results here. It comes out as this crazy thing. Now luckily it didn't crash the program, but it certainly gives a very unusual result. And that's what's happened in that situation, is that the roots are not calculatable. You might wonder, what does that look like as an actual diagram? Well, in effect, it's either something like this, which has not managed to cross the x-axis in that direction, or it's something like this, which has not managed to cross the x-axis in that direction. And therefore, remember that the roots of the equation are where it crosses the x-axis, and because they don't actually cross the x, it doesn't have roots, or not, at least not real roots, and therefore we end up with a funny thing happening. So if you find that you're getting that as an answer and you think there's something wrong with your program, in actual fact that's just to do with the type of numbers that you're putting in. So make sure you know what numbers you're putting in, and therefore what answer you expect to get. So that's it for the wrap-up lecture on that week. So we'll leave it at that.